There is a black hole so massive, so impossibly vast, that if you placed it where our sun sits right now, its shadow would swallow everything we have ever known. Mercury would be gone. Venus would be gone. Earth, Mars, Jupiter, Saturn, and even the lonely frozen plains of Neptune, all of it would vanish inside a darkness so complete that light itself cannot escape. This is not science fiction. This is not a guess. This is real, and astronomers have found it lurking in the heart of a distant galaxy, waiting in the cosmic dark like a silent giant that has been feeding for billions of years. If you are enjoying this journey through the cosmos, take a moment to hit the like button and subscribe to Cosmic Drift. Your support helps us explore the deepest mysteries of the universe together, and we have so much more to discover. Now, let us talk about how something like this is even possible. How does a single point in space grow to become larger than our entire solar system? How does gravity become so strong that it bends time itself? And what would happen to you, to your body, to your very thoughts, if you drifted too close to this cosmic monster? These are the questions that have puzzled scientists for decades. And tonight, as you settle into a comfortable position and let your breathing slow, we are going to explore them together. We are going to journey to the edge of the known universe and peer into the abyss that holds galaxies together. We are going to meet the shadow that devours sunsets. Picture our solar system for a moment. Start at the sun, that burning ball of fire that gives us warmth and light. Now imagine traveling outward, past the rocky inner worlds where humans live, past the giant gas planets that spin in their ancient orbits, past the rings of Saturn that glitter like diamond dust scattered across black velvet. Keep going. Move beyond the ice giants, beyond the dwarf planets that drift in the frozen darkness at the edge of our cosmic neighborhood. Out here, the sun is just another bright star in a sky full of distant lights. Out here, it takes radio signals hours to reach home. This is the boundary of our solar system, a bubble of space roughly 90 times the distance from Earth to the sun. Now, imagine dropping something into the center of all this. Imagine a sphere of pure darkness, a region where gravity has become so strong that nothing, not light, not matter, not even information, can ever leave. Imagine this sphere growing larger and larger until its edge, the point of no return that scientists call the event horizon, stretches past Mercury, past Venus, past Earth, past Mars. Watch it grow until it swallows Jupiter and all its moons. Watch it expand until Saturn disappears, until Uranus and Neptune are just memories. Watch it keep growing until the entire orbit of our most distant planets fits comfortably inside its shadow. This is the scale we are talking about tonight. This is the size of the black holes that anchor the largest galaxies in the universe. They are called supermassive black holes, and they are nothing like the smaller black holes that form when giant stars collapse at the end of their lives. Those stellar black holes are frightening enough. Little points of darkness perhaps 10 or 20 times the mass of our sun, capable of ripping apart any object that wanders too close. But the giants we are discussing tonight are something else entirely. They contain the mass of millions, billions, even hundreds of billions of suns, all compressed into a single region of space where the normal rules of physics break down completely. Think about that for a moment as you feel your body relaxing into whatever surface supports you. Let your muscles soften. Let your thoughts slow down. We are going to spend some time with these cosmic giants, and there is no rush. The black holes have been there for billions of years. They will wait for us. The first thing to understand about a supermassive black hole is that it does not actually suck things in the way a vacuum cleaner pulls dust from a carpet. This is a common misunderstanding, one of those ideas that sounds right but misses the deeper truth. A black hole is not a cosmic drain that actively reaches out and grabs nearby objects. Instead, it is simply a region of space where mass has become so concentrated that gravity, the same gentle force that keeps your body pressed against your bed right now, becomes overwhelming. Think of it like this. Imagine you are standing on a trampoline, one of those big ones with a stretchy surface that bounces when you jump. If you stand perfectly still in the middle, you create a little dip in the fabric. This dip is your gravity, your mass bending the surface of the trampoline. Now imagine someone rolls a marble across the trampoline from the edge. If the marble is moving fast enough and at the right angle, it might curve around you and roll off the other side. But if it is moving slowly or too close to the center, it will spiral inward and come to rest next to your feet. A black hole is like someone standing on that trampoline who weighs so much that they have torn a hole right through the center. Anything that gets too close to that hole will fall in, not because the hole is reaching out and grabbing it, but simply because the shape of space itself has become a one-way street pointing downward. Once you cross a certain boundary, there is no amount of speed, no engine powerful enough, no force in the universe strong enough to carry you back out. You can only fall. This boundary is the event horizon, and for the supermassive black holes we are discussing tonight, this boundary is incomprehensibly large. The event horizon of a stellar black hole, the kind formed from a collapsed star, might only be a few miles across. You could drive around it in a car in a matter of minutes if such a journey were possible. But the event horizon of a supermassive black hole can be larger than our entire solar system. Light itself, the fastest thing in the universe, would take hours to travel from one side to the other if it could somehow hover at the edge without falling in. Let your mind drift with that image for a moment. A sphere of darkness so vast that light takes hours to cross it. A region of space so warped that anything entering it is cut off from the rest of the universe forever. This is not a small thing hiding in the depths of space. This is a cosmic landmark, a signpost that marks the center of the largest structures in existence. Every major galaxy appears to have one of these giants at its core. Our own Milky Way, the band of light that stretches across the night sky when you stand far from city lights, is anchored by a supermassive black hole called Sagittarius A star. This black hole contains about 4 million times the mass of our Sun, and yet it is considered modest by cosmic standards. It is a quiet giant, dozing in the center of our galaxy, not currently feeding on large amounts of matter. We are fortunate in some ways that our galaxy's central black hole is so peaceful. In other galaxies, these giants are anything but calm. To understand what happens when a supermassive black hole is actively feeding, we need to travel far beyond the Milky Way. We need to look at galaxies where the central black hole is surrounded by a swirling disk of material, a cosmic whirlpool of gas and dust, and shattered stars that spiral slowly inward toward the event horizon. This structure is called an accretion disk, and it is one of the most violent and energetic environments in the entire universe. Picture a drain in a bathtub. When you pull the plug, the water does not simply drop straight down. Instead, it spirals around the drain, moving faster and faster as it gets closer to the center. The same thing happens around a supermassive black hole, but instead of water, we are talking about vast clouds of hydrogen gas, entire stars that wandered too close, and cosmic debris that has been accumulating for millions of years. All of this material spirals inward, compressed and heated by friction and gravity until it begins to glow. And when I say glow, I do not mean the gentle warmth of a candle flame or the soft light of a lamp beside your bed. The accretion disk around an active supermassive black hole can shine brighter than all the stars in its galaxy combined. Billions of suns worth of light pouring out from a region smaller than our solar system. This light can be seen across unimaginable distances, a beacon burning in the cosmic dark that tells astronomers where these giants lurk. These actively feeding black holes are called quasars, and when they were first discovered in the 1960s, they baffled scientists completely. Here were objects that appeared star-like in photographs, just tiny points of light like any other star. But when astronomers measured how far away they were, the numbers made no sense. These tiny points of light were billions of light-years distant, far beyond any star we could possibly see. For them to be visible at such distances, they would have to be generating more energy than anyone thought possible. It took years for scientists to piece together the truth. What they were seeing was not a star at all. It was a supermassive black hole surrounded by an accretion disk, so bright that it could outshine an entire galaxy. The light they detected had been traveling through space for billions of years, starting its journey when the universe was young and galaxies were still forming. In some ways, looking at a quasar is like looking back in time, seeing the universe as it existed when supermassive black holes were more active, when more material was available for them to consume. But here is where the mystery deepens, and this is the part that keeps astronomers awake at night, puzzling over equations and running simulations on supercomputers. These supermassive black holes are simply too big. They should not exist, at least not according to our understanding of how black holes grow. Let me explain what I mean. A black hole grows by consuming matter. When gas or dust or an unfortunate star falls past the event horizon, its mass gets added to the black hole, making it slightly larger and heavier. This process is called accretion, and it has a natural speed limit. As material falls inward and heats up, it generates radiation, light, and other forms of energy that push outward against the incoming material. This outward pressure limits how fast matter can fall into the black hole, creating what scientists call the Eddington limit. Think of it like trying to drink from a fire hose. The water is coming at you so fast that some of it splashes back, preventing you from swallowing as quickly as you might want. A black hole facing the Eddington limit has a similar problem. The radiation from its accretion disk pushes back against the incoming material, limiting how fast the black hole can grow. If supermassive black holes started out small and grew by consuming matter at the Eddington limit, they simply would not have had enough time to reach their current sizes. The universe is about 13.8 billion years old, and some of these giants contain hundreds of billions of solar masses. Even if they had been feeding constantly since the Big Bang, they should not be as large as they are. Something does not add up. This is one of the great puzzles of modern astronomy. How did these cosmic monsters get so big so fast? There are several possibilities that scientists are exploring, and each one paints a different picture of how the early universe worked. One idea is that supermassive black holes did not start out small. Instead of forming from the collapse of ordinary stars, perhaps they began as massive seeds, objects containing tens of thousands of solar masses that appeared when the universe was very young. These seeds could have formed when enormous clouds of primordial gas collapsed directly into black holes without ever becoming stars first. Starting with such a large seed would give these black holes a head start, allowing them to reach their current sizes more easily. Another possibility is that the Eddington limit is not as strict as we thought. Under certain conditions, perhaps matter can fall into a black hole faster than the limit suggests. If the accretion disk is thick and opaque, the radiation might get trapped inside, unable to push back against the incoming material. This would allow periods of super Eddington accretion, rapid growth spurts that could help explain how these giants became so massive. A third idea involves black hole mergers. When galaxies collide, which happens frequently over cosmic timescales, their central black holes may eventually spiral together and merge into a single, larger black hole. If this process happened many times over billions of years, smaller black holes could combine to form the supermassive giants we see today. The truth might involve all of these processes working together. The early universe may have produced large seeds that then grew through a combination of rapid accretion and mergers, building up to billions of solar masses over cosmic time. We do not yet know which scenario is correct, but new telescopes and observations are helping us narrow down the possibilities. Let your thoughts drift with these ideas for a moment. Somewhere in the distant universe, right now, matter is spiraling into a supermassive black hole. Hydrogen atoms that formed in the first few minutes after the Big Bang are falling, past an event horizon from which they will never return. Stars that might have hosted planets with civilizations of their own are being torn apart by tidal forces, stretched into ribbons of glowing plasma before disappearing forever. The universe is vast and ancient, and these processes have been happening for billions of years before humans ever looked up at the night sky and wondered what was out there. Now let us talk about what happens near one of these giants. Let us imagine you are an astronaut in some impossibly advanced spacecraft, and you have traveled to the edge of a supermassive black hole to see it for yourself. What would you experience? What would you see? And what would happen to time itself as you approach the event horizon? The first thing you would notice is the distortion of the stars around you. A black hole bends light with its gravity, acting like a lens that warps everything behind it. Stars that should be hidden behind the black hole would instead appear to smear around its edges, their light bent into rings and arcs by the intense gravitational field. This effect is called gravitational lensing, and it turns the space around a black hole into a funhouse mirror where nothing is quite where it appears to be. As you got closer, you would begin to see the accretion disk, assuming the black hole was actively feeding. This disk would not look like a flat ring when viewed from certain angles. Because the black hole bends light so strongly, you would actually see the far side of the disk warped up and over the top of the black hole, and also bent underneath it. The disk would appear to wrap around the darkness in strange and beautiful ways, a glowing ribbon of fire twisted by gravity into impossible shapes. The darkness at the center would be absolute. No light escapes from beyond the event horizon, so you would see nothing there. Just a perfect black circle where the universe simply ends. This is the shadow of the black hole, the region where everything that falls in is lost forever. It is darker than the darkest night on Earth, darker than the space between stars, a complete absence of light that marks the boundary of our physical understanding. But perhaps the strangest thing you would experience is what happens to time. According to Einstein's theory of relativity, gravity affects the passage of time. The stronger the gravitational field, the slower time moves compared to regions with weaker gravity. This is not just a theoretical curiosity. It is a real effect that we can measure with precise clocks here on Earth. Clocks at higher altitudes tick very slightly faster than clocks at sea level because they are further from Earth's center and experience slightly weaker gravity. Near a black hole, this effect becomes extreme. As you approach the event horizon, time for you would slow down dramatically compared to someone watching from a safe distance. If you could somehow hover just outside the event horizon and send radio signals back to a friend waiting far away, those signals would become stretched and redshifted, arriving less and less frequently as the time dilation increased. From your perspective, everything would feel normal. Your heart would beat at the same rate, your thoughts would flow at the same speed, and your coffee would cool just as quickly as it always does. But if you looked back at the universe outside, you would see it speeding up. Stars would be born and die in what seemed like moments. Galaxies would spin faster. The entire history of the cosmos would unfold before you in an accelerated blur while you hung suspended at the edge of eternity. For the friend watching from far away, the effect would be reversed. They would see you slow down as you approach the event horizon. Your movements would become sluggish. Your radio messages would stretch into low-frequency rumbles, and your image would freeze as you seemed to hover at the edge forever, never quite crossing over. In reality, you would have fallen in long ago from your own perspective. But the light carrying your final image would be so stretched by time dilation that it would take an eternity to reach your distant observer. This is one of the most mind-bending aspects of black hole physics. The event horizon is not just a boundary in space. It is a boundary in time. Crossing it means leaving the universe behind in a very real sense, entering a region where the future points only in one direction, toward the singularity at the center, where all matter is crushed into an infinitely small point. What happens at that singularity? This is where our current understanding breaks down completely. According to general relativity, the singularity is a point of infinite density, a place where the equations stop working and spit out answers of infinity. Most physicists believe that this breakdown indicates a gap in our knowledge, a place where a new theory, perhaps one that combines gravity with quantum mechanics, is needed to describe what really happens. Some theorists have proposed that matter falling into a black hole does not simply vanish. Perhaps it emerges somewhere else, in another region of space-time, through a structure called a white hole. Perhaps it gets scrambled and encoded on the event horizon, preserved in some way we do not yet understand. Perhaps it contributes to the formation of new universes, baby cosmoses budding off from our own. These ideas are speculative, the kind of thinking that stretches the boundaries of current physics, but they reflect the genuine mystery that surrounds these objects. For now, let yourself rest with the uncertainty. The universe does not demand that we understand everything. It simply exists in all its vastness and strangeness, offering puzzles for curious minds to contemplate. The black holes will keep their secrets for a while longer, and that is perfectly fine. Some mysteries are worth savoring. As you lie there in the quiet of this moment, let us turn our attention to one of the most impressive supermassive black holes ever discovered. Its name is TON 618, and it sits at the center of a distant quasar, a lighthouse of destruction burning in a galaxy far across the visible universe. When astronomers first measured its mass, the numbers were almost impossible to believe. This single object contains somewhere between 60 and 70 billion times the mass of our Sun. Some estimates suggest it could be even larger, perhaps approaching 100 billion solar masses. To put that in perspective, remember that our entire Milky Way galaxy contains roughly 100 billion stars. TON 618, a single black hole, may weigh as much as all the stars in our galaxy combined. It is not just a giant. It is a titan among giants, one of the most massive objects we have ever found in the entire observable universe. The event horizon of TON 618 stretches across a distance roughly equal to 11 times the size of our solar system. If you could somehow see it directly, it would appear as a vast dark sphere larger than any structure humanity has ever built, larger than any planet or star, a piece of absolute night hanging in the cosmic void. Light that enters that region is gone forever, adding its energy to the ever-growing mass of the black hole. TON 618 is not feeding quietly. It is actively consuming matter at a tremendous rate, and the accretion disk surrounding it blazes with the light of entire galaxies. When we look at it from Earth, we see a quasar, a point of brilliant light that has been shining across the universe for billions of years. The photons reaching our telescopes today left TON 618 when the universe was much younger, when galaxies were still forming and supermassive black holes were more active than they typically are now. There is something humbling about knowing that such a monster exists. It will never threaten Earth. It is far too distant, separated from us by billions of light years of empty space. But it reminds us of the extremes that nature can achieve when gravity and time work together across cosmic scales. The universe is not a gentle place. It contains objects of such power and violence that our minds struggle to truly comprehend them. And yet, here we are, tiny creatures on a tiny planet, looking up at the sky and piecing together the story of these distant giants. But TON 618 is not the only candidate for the title of largest known black hole. In recent years, astronomers have discovered another contender lurking in a galaxy cluster called Abel 2029. This black hole is named Phoenix A star, and it may be even more massive than TON 618. Phoenix A star sits at the center of a galaxy that itself sits at the center of a massive cluster of galaxies. This galaxy cluster is one of the most extreme environments in the nearby universe, a dense concentration of thousands of galaxies all bound together by gravity, with vast clouds of hot gas filling the space between them. At the very heart of this cosmic metropolis, Phoenix A star has been growing for billions of years, fed by streams of gas cooling out of the surrounding environment. Early estimates suggested that Phoenix A star might contain as much as 100 billion solar masses, making it potentially the largest black hole we have ever found. More recent measurements have refined this number, but it remains one of the most massive objects known to exist. Its event horizon would be large enough to fit multiple solar systems inside, a boundary of no return that marks the edge of everything we understand about physics. What makes Phoenix A star particularly interesting to scientists is the environment in which it lives. Most supermassive black holes seem to have stopped growing. Their host galaxies have used up most of the available gas, and without new fuel, the black holes sit quiet and dormant. But Phoenix A star is different. The surrounding galaxy cluster contains vast reservoirs of hot gas that are slowly cooling and falling inward, providing a steady supply of food for the central black hole. This suggests that Phoenix A star may still be growing, adding to its already staggering mass with each passing year. The rate of this growth is astonishing. Astronomers estimate that Phoenix A star may be consuming the equivalent of several hundred solar masses of material every year. That is several hundred stars worth of gas and dust spiraling past the event horizon annually, converted into pure mass that adds to the black hole's gravitational pull. Over millions of years, this steady feeding could push Phoenix A star to even more extreme sizes. Let these numbers wash over you without trying to hold them too tightly. The universe operates on scales that human intuition was never designed to grasp. We evolved to understand the world of trees and rivers, of hunting and gathering, of social relationships within small groups of fellow humans. Nothing in our evolutionary history prepared us to comprehend objects containing 100 billion solar masses, or distances measured in billions of light years. And yet, through mathematics and observation, through patient study and creative thinking, we have managed to extend our understanding far beyond the world of our ancestors. That is perhaps the most remarkable thing about being human. We can know things that we cannot truly feel, understand things that we cannot truly imagine. As you rest and let your breathing continue in its slow, easy rhythm, consider the role these supermassive black holes play in shaping the universe around them. They are not just passive collectors of matter, sitting at galaxy centers like drains waiting for debris to fall in. They are active participants in the evolution of their host galaxies, influencing the birth of stars across vast regions of space. When a supermassive black hole feeds actively, it does not just consume matter, it also expels enormous amounts of energy. The accretion disk surrounding an active black hole can launch jets of particles traveling at nearly the speed of light, narrow beams of energy that shoot outward from the poles of the spinning black hole. These jets can extend for millions of light years, punching through the surrounding galaxy and out into the emptiness between galaxies. They carry enough energy to heat entire galaxy clusters, preventing gas from cooling and forming new stars. This feedback process is one of the most important mechanisms in the universe for regulating galaxy growth. Without it, galaxies might become far more massive than they currently are, filled with many more stars than we observe. The black hole at the center acts like a thermostat, occasionally flaring up and dumping energy into its surroundings when too much gas tries to fall inward. This keeps the galaxy in a kind of balance, neither growing too quickly nor collapsing under its own weight. Scientists call this relationship between a black hole and its host galaxy coevolution. The black hole and the galaxy influence each other, growing together over cosmic time in a dance that has been ongoing for billions of years. When a galaxy merges with another galaxy, their central black holes eventually find each other and combine, creating a larger black hole at the center of the merged system. As the new galaxy settles into its final shape, the black hole may go through periods of active feeding, shaping the distribution of gas and stars around it. Over time, both the galaxy and its black hole reach something like an equilibrium, their masses correlated in ways that suggest a deep underlying connection. This correlation is one of the most surprising discoveries of modern astronomy. Supermassive black holes are tiny compared to their host galaxies. The black hole at the center of the Milky Way has a mass of about 4 million solar masses, while the entire galaxy contains hundreds of billions of solar masses. The black hole is less than 1/100th of 1% of the galaxy's total mass. And yet, somehow, the mass of the black hole is tightly correlated with properties of the surrounding galaxy, particularly the mass of stars in the central bulge region. How does the galaxy know how big its black hole should be, and vice versa? This is another puzzle that astronomers are still working to solve. One clue comes from those energetic jets and outflows we mentioned earlier. When a black hole feeds actively, it pumps energy into the surrounding gas, heating it up and pushing it outward. This can shut off star formation in the central regions of the galaxy, limiting how many stars can form there. If the black hole grows too large, its feedback becomes so strong that it cuts off its own food supply, preventing further growth. If the black hole is too small, feedback is weak, allowing more gas to fall in and the black hole to grow. Over billions of years, this self-regulating process might naturally lead to the correlations we observe. Think of it like a predator-prey relationship in an ecosystem. If there are too many wolves, they eat all the deer and then starve. If there are too few wolves, the deer population explodes and overgrazes the land. Over time, a balance emerges where the populations regulate each other. Supermassive black holes and their host galaxies may work in a similar way, each one's growth limiting the other until they reach a stable relationship. This is a beautiful idea, the notion that galaxies and their black holes are partners in a cosmic dance that has been playing out across the universe for most of its history. Every major galaxy we can see, including our own Milky Way, carries a black hole at its heart. These objects are not just monsters lurking in the dark. They are essential components of galactic structure, shapers of the universe as we know it. Let us stay with this idea for a while longer. The Milky Way, that glowing river of stars that ancient peoples thought might be spilled milk from the gods, is anchored by a black hole called Sagittarius A. This black hole is quiet now. It is not actively feeding, not surrounded by a brilliant accretion disk or launching relativistic jets into the void. But it was not always so peaceful. Evidence suggests that Sagittarius A has had active periods in the past. Giant bubbles of gas extending above and below the plane of our galaxy, discovered in recent decades by space telescopes, may be the remnants of powerful outbursts from our central black hole millions of years ago. These bubbles, called the Fermi bubbles, after the telescope that detected them, stretch for tens of thousands of light years, towering structures of hot gas that glow in gamma rays and radio waves. Imagine what it might have been like if Earth existed during one of those active phases. Our distant ancestors might have looked up at the night sky and seen not just a band of stars, but also strange glowing clouds rising from the center of the galaxy, the aftermath of our black hole's feasting. The light from such an event would have taken tens of thousands of years to reach Earth, arriving long after the outburst itself had ended. But the sky would have looked different than it does tonight, marked by the influence of our galaxy's sleeping giant. Today, Sagittarius A is dormant, but not dead. Occasionally, a cloud of gas or an unlucky star wanders too close, providing a small meal that causes a brief flare of activity. Astronomers have detected these flares, sudden brightening of the X-ray and infrared emission from the galactic center as material falls toward the event horizon. These events are minor compared to what happens in distant quasars, but they remind us that our black hole is still there, still waiting, still capable of activity if enough food comes its way. In about 4 billion years, our situation may change dramatically. The Milky Way is currently on a collision course with the Andromeda Galaxy, our nearest major galactic neighbor. These two spiral galaxies are approaching each other at tremendous speed, drawn together by their mutual gravitational attraction. When they finally collide, the merger will take hundreds of millions of years, a slow-motion catastrophe that will reshape both galaxies beyond recognition. During this collision, the supermassive black holes at the centers of both galaxies will eventually find each other. At first, they will orbit at great distances, gradually spiraling closer as gravitational interactions rob them of energy. Eventually, they will merge into a single, larger black hole, releasing a burst of gravitational waves that will ripple across the cosmos. This merged black hole will sit at the center of the new combined galaxy, a monument to the collision that created it. Will any humans be around to witness this event? 4 billion years is an unimaginably long time. Our sun will have nearly exhausted its nuclear fuel by then, beginning its transformation into a red giant star that will expand outward and possibly swallow the Earth. But perhaps by that time, if our species survives, we will have spread to other star systems, other planets, other places in the galaxy where we can watch the merger from a safe distance. The universe unfolds on timescales that dwarf individual human lives, but our species might persist, might adapt, might find ways to continue the story we have barely begun to write. For now, though, let us return to the present moment. You are here, resting in comfort, listening to these words describe wonders that exist across vast distances. The black holes we have discussed are real. They are out there right now, bending space and time around them, feeding on matter that will never return to the wider universe. And yet, despite their violence and their strangeness, they are part of the same cosmos that gave birth to Earth, to life, to you. The atoms in your body were forged in stars that died long ago, and some of those stars may have been influenced by the very black holes we have been discussing. Everything is connected in the vast web of cosmic evolution. There is a particular kind of peace that comes from contemplating these connections. When you look up at the night sky, you are not separate from what you see. You are made of the same stuff, shaped by the same forces, participating in the same unfolding story. The black holes are distant and strange, but they are not truly alien. They are expressions of the same physical laws that govern the beating of your heart and the flow of your breath. Gravity, the force that shapes black holes, is the same force that keeps your feet on the ground and makes raindrops fall. We live in a universe where the familiar and the exotic are ultimately different manifestations of the same underlying reality. As we continue this journey into the cosmic dark, let your body sink a little deeper into relaxation. Notice how your shoulders feel, and if you are holding any tension there, see if you can let it go. Notice your jaw, and if it is clenched, allow it to soften. These are such simple things, these little adjustments of the physical body, and yet they can make such a difference in how we feel. The universe is vast and ancient and filled with wonders beyond counting, and you are here, warm and safe, taking it all in at your own pace. Let us talk now about what these supermassive black holes mean for the far future of the universe. We have discussed how they formed, how they grew, how they influence their surroundings, but what will happen to them as cosmic time stretches on toward infinity? The universe is expanding. Every galaxy is moving away from every other galaxy, carried along by the stretching of space itself. This expansion has been happening since the Big Bang, and it appears to be accelerating, driven by a mysterious force that scientists call dark energy. If this acceleration continues, the future of the universe will be strange and lonely. Over billions of years, the expansion of space will carry all the distant galaxies beyond our observable horizon. One by one, the lights in the sky will wink out, not because the galaxies are dying, but because the light they emit can no longer reach us, stretched by the expansion into radio waves and then into nothing at all. Eventually, the only galaxies left in our observable universe will be those bound to our own local group by gravity, primarily the merged remnant of the Milky Way and Andromeda, that astronomers sometimes call Milkdromeda. Inside this merged galaxy, stellar evolution will continue for a while. New stars will form from the available gas, shine for millions or billions of years, and then die, adding their ashes to the interstellar medium. But the supply of gas is finite. Eventually, all the hydrogen will be used up, and no new stars will form. The galaxy will fade as its existing stars burn out one by one. The last stars to shine will be the red dwarfs, tiny dim stars that burn their fuel so slowly they can last for trillions of years. Long after our sun has faded to a cold white dwarf, these patient little stars will still be glowing, providing the only warmth in a universe growing steadily darker and colder. But even they will eventually exhaust their hydrogen and flicker out. What happens to the supermassive black holes during this long twilight? They persist. Unlike stars, which shine because of nuclear fusion and eventually run out of fuel, black holes do not consume themselves. They simply exist, their gravity reaching out into the surrounding space, capturing anything that happens to fall too close. In the far future, the black holes will be among the most important objects left in the universe. Stars that wander too close will be captured and consumed, their mass added to the ever-growing giants at galaxy centers. Stellar remnants, white dwarfs, neutron stars, and smaller black holes will gradually spiral inward over unimaginable timescales, contributing to the growth of the central monsters. But there is a catch. Even black holes are not eternal. According to the work of physicist Stephen Hawking, black holes slowly evaporate through a quantum mechanical process now called Hawking radiation. Near the event horizon, quantum fluctuations in the fabric of space can create pairs of virtual particles. Sometimes, one particle of the pair falls into the black hole while the other escapes, carrying energy away. Over time, this process causes the black hole to lose mass, shrinking ever so slowly. For the supermassive black holes we have been discussing, this evaporation takes an almost incomprehensibly long time. A black hole containing billions of solar masses would take something like 10 to the 100th power years to fully evaporate. That number is so large that it makes the current age of the universe look like the blink of an eye. For all practical purposes, these black holes are permanent fixtures of reality, outlasting stars, planets, and perhaps even the atoms themselves. But eventually, in the unimaginably distant future, even the mightiest black holes will fade away. Their last moments will be violent, as Hawking radiation increases dramatically when a black hole shrinks to extremely small sizes. The final evaporation will release a burst of particles and radiation, a last gasp of energy marking the end of objects that once ruled galaxies. When the last black hole evaporates, what will remain? A universe of scattered particles, thinned by expansion into a diffuse gas approaching absolute zero. Photons stretched by billions of years of cosmic expansion into radio waves of vanishingly small energy. A cosmos empty of structure, empty of light, empty of the complex phenomena that we call life. This is the heat death of the universe, the final state toward which everything seems to be heading. It is a melancholy vision in some ways, this picture of a universe winding down into darkness and cold. But it is also a reminder of how precious the present moment is. We exist in a brief window of cosmic history, a time when stars still shine and planets can form, and life can emerge and contemplate its own existence. The universe has not always been this hospitable, and it will not always remain so. We are fortunate to be here now, in this age of light, and besides, predictions about the far future are uncertain. Perhaps some new phenomenon will intervene, some process we do not yet understand that will change the ultimate fate of the cosmos. The universe has surprised us before. It may do so again. For now, as you rest in this moment, let the vastness of cosmic time be a backdrop rather than a burden. The black holes that anchor galaxies have been there since the universe was young. They will be there long after Earth is gone. And yet, here you are, able to think about them, able to wonder about them, able to feel something in response to their existence. That is a remarkable thing. Consciousness arising from matter, awareness emerging from the dance of atoms and energy that plays out across the cosmos. Let us shift our attention now to something more immediate, more personal. What would it actually feel like to fall into a supermassive black hole? We touched on some aspects of this earlier, the time dilation and the warped appearance of stars. But let us explore the experience in more detail, imagining a journey that no human will likely ever make, but which physics allows us to describe. Suppose you were falling feet first toward the event horizon of a supermassive black hole, one of the giants like TON 618 or Phoenix A star. As you approached, you would notice the strange visual effects we discussed, stars smearing into rings around the black hole, the accretion disk wrapping up and over and under the central darkness. If you had instruments to measure your local environment, they would tell you that space itself was becoming more and more curved, that the geometry of the universe around you was warping in ways that would seem impossible on Earth. But here is the surprising thing about supermassive black holes. Because they are so large, the tidal forces at the event horizon are actually quite gentle. Tidal forces are the difference in gravitational pull between one point and another. On Earth, the moon's gravity creates tides in the ocean because it pulls a little harder on the side of our planet facing it and a little less on the side facing away. This difference in pull is small, but enough to move water. Near a black hole, tidal forces can be extreme. If you fell toward a stellar, mass black hole, one containing only 10 or 20 solar masses, the tidal forces would tear you apart long before you reach the event horizon. The gravity pulling on your feet would be so much stronger than the gravity pulling on your head that you would be stretched like taffy, a process colored, and then eventually you would approach the singularity. What happens there, no one knows. Perhaps the tidal forces finally become strong enough to destroy you. Perhaps you encounter something utterly new, a realm where the normal laws of physics no longer apply. Perhaps the singularity is not really a point at all, but a gateway to something else, another universe, another form of existence, another chapter in a story we cannot begin to imagine. This is where science reaches its limits and speculation begins. The singularity is hidden behind the event horizon, cut off from the rest of the universe. We can never observe it directly, never send a probe to report back on what it finds. All we have are mathematical models that break down when they try to describe what happens there. Until we have a complete theory of quantum gravity, a framework that combines Einstein's general relativity with the quantum mechanics that governs the very small, the singularity will remain a mystery wrapped in darkness. Some physicists believe that a theory of quantum gravity will reveal that singularities do not really exist. Perhaps quantum effects smooth out the infinite densities, replacing the singularity with something finite but still extreme. Perhaps space-time itself is quantized, made of discrete chunks at the smallest scales, and this graininess prevents true infinities from forming. We do not know yet. The answers lie at the frontier of human understanding, waiting to be discovered. Let your mind rest in this uncertainty. There is a kind of peace in acknowledging what we do not know, in accepting that the universe still holds secrets that will take generations to unravel. The black holes remind us of our limitations, even as they demonstrate the power of human curiosity. We have learned so much about these objects, despite never being able to visit one. We have inferred their properties from light that traveled across billions of years to reach our telescopes. We have built models and tested predictions and slowly pieced together a picture of what these cosmic monsters are and how they behave. That is an astonishing achievement, a testament to the power of the scientific method and the persistence of human wonder. As you continue to relax, let us talk about how we know all this. How have astronomers learned about black holes if they cannot see them directly? What evidence convinced scientists that these objects are real, not just mathematical curiosities dreamed up by theorists? The story begins over a century ago, with Albert Einstein's theory of general relativity. In 1915, Einstein published a set of equations that described gravity not as a force reaching across space, but as the curvature of space-time itself. Massive objects bend the fabric of the cosmos around them, and other objects move along the curves of this bent fabric, tracing paths that we perceive as gravitational attraction. Einstein's equations were beautiful and elegant, but they also contained strange possibilities. Shortly after the theory was published, a German physicist named Karl Schwarzschild found a solution to the equations that described the space-time around a perfectly spherical, non-rotating mass. This solution, now called the Schwarzschild solution, revealed something unexpected. If you compressed enough mass into a small enough region, you would create a point from which nothing could escape, not even light. The boundary of this region, the event horizon, would mark a one-way door in space-time. At first, most physicists, including Einstein himself, thought these objects were mathematical oddities that would never exist in nature. Surely no real process could compress matter enough to create such an extreme configuration. But as the decades passed, and astrophysicists learned more about stellar evolution, it became clear that massive stars could indeed collapse into these bizarre states when they exhausted their nuclear fuel. The first strong evidence for black holes came from X-ray observations in the 1960s and 70s. Astronomers discovered sources of intense X-ray radiation in the sky, points of high energy light that seemed to be associated with binary star systems. In some of these systems, one member was a normal star, while the other was invisible, detectable only by its gravitational effects on its companion. The invisible object was too massive to be a white dwarf or a neutron star. The other types of collapsed stellar remnants. The only explanation that fit the observations was a black hole, an object so dense that not even light could escape its surface, explaining why it was invisible. The X-rays came from gas stripped off the normal star and heated to extreme temperatures as it spiraled toward the event horizon. Since then, the evidence for black holes has only grown stronger. Astronomers have tracked the orbits of stars near the center of our own galaxy, watching them whip around an invisible point at incredible speeds. These observations earned a Nobel Prize and provided the strongest evidence yet for the existence of Sagittarius A star, the supermassive black hole at the heart of the Milky Way. In 2019, the Event Horizon Telescope collaboration released the first direct image of a black hole, or rather, of the bright ring of light surrounding its dark shadow. This image showed the supermassive black hole at the center of the galaxy Messier 87, a giant containing about 6.5 billion solar masses. The image looked remarkably like what theorists had predicted, a glowing ring of hot gas surrounding a central darkness where light from the accretion disk was blocked by the black hole's shadow. More recently, astronomers have detected gravitational waves, ripples in space-time itself, produced when black holes collide and merge. These detections, made possible by exquisitely sensitive instruments called interferometers, have opened a new window on the universe. We can now study black holes not just through the light they emit or block, but through the very vibrations they produce in the fabric of space. all of this evidence converges on the same conclusion. Black holes are real. They are scattered throughout the universe, from stellar mass objects formed in supernova explosions to the supermassive giants that anchor galaxy centers. Their properties match what Einstein's theory predicted over a century ago, and studying them continues to reveal new insights about the nature of space, time, and gravity. It is worth pausing for a moment to appreciate how remarkable this is. Black holes were once considered theoretical curiosities, mathematical ghosts that might not correspond to anything in the real universe. Now, they are established members of the cosmic zoo, objects that astronomers observe routinely, phenomena that generate real data, that fills databases and spawns research papers. The universe is stranger than we imagined, and the discovery of black holes is one of the great scientific triumphs of the past century. As you rest and let these ideas settle in your mind, consider the role of technology in making these discoveries possible. The human eye is a wonderful instrument, but it can only perceive a narrow range of the electromagnetic spectrum, the band of visible light that spans from red to violet. The universe, however, radiates across a much wider range, from radio waves with wavelengths stretching for miles, to gamma rays with wavelengths smaller than atoms. To see black holes and their effects, astronomers have built telescopes that operate across this entire spectrum. Radio telescopes reveal the jets of plasma shooting from active galactic nuclei. Infrared telescopes penetrate the dust that shrouds galaxy centers, allowing us to see the stars orbiting supermassive black holes. X-ray telescopes detect the hot gas swirling in accretion disks, heated to millions of degrees by friction and compression. Gamma-ray telescopes capture the most energetic radiation, marking the locations of the most violent events in the cosmos. The Event Horizon telescope that imaged the black hole in Messier 87 was not a single dish, but a network of radio telescopes scattered around the world, linked together to form an Earth-sized virtual telescope. The angular resolution of this combined instrument was sharp enough to see a tennis ball on the moon from Earth. That is the kind of precision needed to resolve the shadow of a black hole millions of light years away. Gravitational wave detectors work on completely different principles. They use laser beams bouncing between mirrors to measure changes in distance of less than 1,000th the width of a proton. When a gravitational wave passes through the detector, it stretches and squeezes space itself, causing the laser beams to travel slightly different distances. By comparing these tiny changes, physicists can detect the rumbles of colliding black holes across cosmic distances. Each of these technologies represents decades of development, thousands of person-years of effort, billions of dollars of investment. The discoveries they enable are the product of global scientific collaboration. Teams of researchers from dozens of countries working together to push the boundaries of what we can observe and understand. This is one of the most hopeful aspects of black hole science. It shows what humanity can achieve when we cooperate, when we channel our curiosity and creativity toward understanding the universe that created us. Let these thoughts accompany you as you continue to relax. The quest to understand black holes is ongoing. New telescopes are being built, new observations are being planned, new theories are being developed. In the years and decades ahead, we will learn more about these cosmic enigmas, perhaps solving some of the puzzles we have discussed tonight, perhaps discovering entirely new mysteries that we cannot yet anticipate. For now, let us return our attention to the scale and majesty of these objects. We have talked about how large supermassive black holes are, how much they weigh, how they influence their surroundings. But let me try one more visualization to help bring this home. Imagine that you could shrink our entire solar system, everything from the Sun to the orbit of Neptune, down to the size of a penny, a small copper coin holding all the planets, all the moons, the asteroid belt, the Sun itself, all of it compressed into a circle you could hold between your fingers. Now imagine placing that tiny penny next to the event horizon of TON 618. The black hole's shadow would loom over that penny the way a skyscraper looms over an ant. You would need 11 of those pennies lined up side by side to span the diameter of the event horizon. 11 solar systems, each containing a star and its attendant worlds, all fitting within the darkness of a single black hole. Or think of it another way. If the Sun were the size of a basketball, then the orbit of Neptune would be about 1.5 miles away. Pluto, farther out, might be 2 or 3 miles distant. Our solar system at basketball scale would fill a good-sized neighborhood. Now imagine a sphere of pure darkness, large enough to swallow that entire neighborhood, and more. An absence of light stretching from your position to somewhere many miles in every direction. That is the shadow cast by the largest black holes we know, monsters of gravity lurking in the centers of distant galaxies. These comparisons strain the imagination precisely because the objects we are describing transcend everyday experience. Our brains evolved to handle the scales of daily life, not the cosmic extremes that astronomers study. And yet, through patient observation and careful thought, we have managed to wrap our minds around these giants at least partially, to build models that predict their behavior and observations that test those predictions. This is the power of science, the ability to extend human understanding beyond the immediate world of the senses into realms that would otherwise remain forever hidden. We cannot visit a supermassive black hole. We cannot feel its gravity or see its shadow with our naked eyes. But we can know it exists, can understand its properties, can appreciate its role in the cosmic drama. That knowing is itself a kind of encounter, a meeting of mind and universe that transcends the limitations of physical travel. As you settle deeper into relaxation, letting your thoughts drift like clouds across a summer sky, consider how small our problems seem against this backdrop. The stresses and worries of daily life, the deadlines and obligations that fill our waking hours, all of them shrink to insignificance when viewed from a cosmic perspective. This is not meant to diminish the reality of human struggles. Your feelings are valid, your challenges are real, and your life matters deeply to you and to those who love you. But there is sometimes comfort in stepping back, in remembering that the universe is vast and ancient and enduring, and that the current moment, however difficult, is just one small chapter in a much larger story. The black holes have been there for billions of years. They will be there for billions more. They do not worry about tomorrow. They do not fear the passage of time. They simply exist, expressions of gravity and space-time following, the laws of physics that govern everything from falling apples to colliding galaxies. There is a certain peacefulness in their persistence, a steadiness that can anchor your own thoughts when they threaten to spiral into anxiety. Breathe slowly and easily. Let each exhale carry away a little more tension, a little more concern. The universe is holding you, supporting you, as it supports everything within it. The same gravity that shapes black holes keeps your body pressed gently against your bed or couch. The same space-time that curves around event horizons also curves, very slightly, around you. You are part of this cosmos, not separate from it, and in that belonging, there is a kind of peace. Let us explore a few more aspects of these remarkable objects before we begin our journey back home. One of the most intriguing, Questions about supermassive black holes concerns their relationship with the galaxies they inhabit. We touched on this earlier, discussing how black holes and galaxies seem to grow together, their masses correlated in ways that suggest a deep connection. But how exactly does this relationship work? What are the mechanisms that link a tiny point of infinite density with a sprawling collection of hundreds of billions of stars? The answer involves the concept of feedback that we mentioned before, but let us dig a little deeper. When a supermassive black hole feeds actively, consuming gas from its surroundings, it does not just absorb matter quietly. The accretion process releases enormous amounts of energy, far more than the fusion reactions that power stars. In fact, the conversion of gravitational potential energy into radiation as matter falls toward a black hole is one of the most efficient energy generation processes in the universe. As gas spirals inward through the accretion disk, it heats up due to friction and compression. The inner regions of the disk can reach temperatures of millions of degrees, causing them to glow in X-rays and ultraviolet light. This radiation pours outward in all directions, pushing against any gas that might otherwise fall inward. The pressure of light itself, what physicists call radiation pressure, can be strong enough to blow matter away from the black hole. In addition to this radiative feedback, many active black holes produce powerful jets of particles. These jets are launched from the regions near the black hole's poles, where magnetic fields thread through the spinning accretion disk and accelerate particles to nearly the speed of light. The jets punch through the surrounding gas of the galaxy and continue outward for tremendous distances, sometimes extending beyond the visible boundaries of the galaxy itself. When these jets slam into the gas surrounding the galaxy, they deposit enormous amounts of energy. This energy heats the gas, preventing it from cooling and collapsing to form new stars. It is like blowing hot air into a cold room, keeping the temperature elevated and preventing frost from forming on the windows. Without this heating, the gas might cool rapidly, fall toward the galaxy center, and form stars at a much higher rate. This process regulates star formation in the galaxy's central regions. When a lot of gas falls toward the black hole feeds actively and pumps energy back into its surroundings, shutting off the flow of new material. When the gas supply diminishes, the black hole quiets down and the feedback weakens, allowing gas to once again accumulate. Over billions of years, this cycle repeats, the black hole and its host galaxy, negotiating an ongoing balance between growth and dormancy. The jets can have effects that extend far beyond the immediate galaxy. In galaxy clusters, where hundreds or thousands of galaxies are bound together by gravity, the central galaxy often hosts an especially massive black hole with particularly powerful jets. These jets heat the hot gas that fills the space between cluster galaxies, preventing it from cooling and forming new galaxies. Without this heating, simulations suggest that galaxy clusters would be far more massive and contain far more stars than we actually observe. This means that supermassive black holes are not just shapers of individual galaxies. They are architects of large-scale cosmic structure, influencing the formation and evolution of some of the largest gravitationally bound systems in the universe. A single black hole sitting at the center of a cluster tens of millions of light-years across can determine how much gas cools, how many stars form, how the cluster evolves over cosmic time. It is a strange thought that something so small compared to its surroundings can have such outsized influence. The black hole at the center of a galaxy cluster might be smaller than our solar system, while the cluster itself spans millions of light-years. And yet, through the lever of feedback, that tiny point of darkness reaches out and touches the entire structure, regulating its growth like a thermostat regulating the temperature of a house. There is a lesson here about the interconnectedness of cosmic systems. Nothing in the universe exists in isolation. Stars form from clouds of gas that were shaped by previous generations of stars. Galaxies merge with other galaxies, combining their black holes and their stellar populations. Clusters form from the gravitational accumulation of many galaxies, each one bringing its own history into the growing structure. And through it all, the black holes at galaxy centers play their role, feeding and quieting, heating and regulating, influencing scales far beyond their own modest sizes. This interconnectedness is one of the beautiful aspects of modern astrophysics. When we study a black hole, we are also studying the galaxy that hosts it, the cluster that contains that galaxy, the cosmic web that links clusters together, and ultimately the entire universe in which all these structures are embedded. Everything is connected, and understanding one piece helps us understand the whole. Let your thoughts relax around this idea of connection. You are connected too, in ways both obvious and subtle. The oxygen you breathe was produced by massive stars that lived and died billions of years ago. The carbon in your cells was forged in stellar cores. The heavier elements, the iron in your blood, the calcium in your bones, were created in supernova explosions that scattered their debris across space. You are literally made of stardust, assembled over billions of years from atoms that have journeyed across the galaxy. Some of those atoms may have passed near the event horizon of Sagittarius A star before eventually finding their way into the cloud of gas that collapsed to form our Sun and its planets. Some may have been heated by the radiation of an active quasar phase, their temperatures raised to millions of degrees before cooling again in the depths of space. The history of the universe is written in the atoms of your body, a chronicle stretching back to the first moments after the Big Bang. This cosmic heritage connects you to the black holes we have been discussing. They are not alien objects existing in some remote corner of reality. They are part of the same universe that gave rise to you, subject to the same laws of physics, participants in the same ongoing story. When you think about a supermassive black hole, you are, in a sense, the universe thinking about itself, consciousness arising from matter to contemplate the extremes of its own existence. Let us talk now about the future of black hole research. What questions remain to be answered? What observations are being planned? What new discoveries might lie ahead? One of the most exciting frontiers involves the study of gravitational waves from supermassive black hole mergers. The gravitational wave detectors that have so far detected collisions between stellar mass black holes are not sensitive to the lower frequency waves produced when supermassive black holes merge. Those waves take years or even decades to complete a single oscillation, far too slow for ground-based detectors to measure. To detect these low-frequency gravitational waves, scientists are developing new techniques. One approach uses pulsars, rapidly spinning neutron stars that emit beams of radiation like cosmic lighthouses. These pulsar signals are incredibly regular, ticking with a precision that rivals the best atomic clocks on Earth. By carefully monitoring an array of pulsars across the sky, researchers can look for the subtle stretches and squeezes of space-time caused by passing gravitational waves. This technique, called pulsar timing array, has already produced intriguing results. In recent years, several pulsar timing collaborations have reported evidence of a background hum of gravitational waves, a chorus of signals that might come from supermassive black hole pairs spiraling together in galaxies throughout the universe. If confirmed, this would be the first detection of gravitational waves from the most massive black holes, opening a new window on the dynamics of galaxy centers. Another future project involves space-based gravitational wave detectors. The Laser Interferometer Space Antenna, or LISA, is a planned mission that would fly 3 spacecraft in a triangular formation millions of miles apart. By bouncing lasers between the spacecraft and measuring tiny changes in the distances, LISA would be able to detect gravitational waves in the frequency range where supermassive black hole mergers produce their strongest signals. When LISA launches, perhaps in the 2030s, it will revolutionize our understanding of these cosmic collisions. The next generation of telescopes will also provide new insights. The upcoming extremely large telescopes being built in Chile and Hawaii will have mirrors many times larger than current instruments, allowing them to gather more light and see finer details. These telescopes will be able to study the environments around supermassive black holes in unprecedented detail, tracking the orbits of stars and gas clouds to map the gravitational field near the event horizon. Radio telescopes continue to improve as well. The next generation Event Horizon Telescope will include more stations and higher frequencies, producing even sharper images of black hole shadows. Perhaps we will be able to see details of the accretion flow, watch the gas swirling around the darkness in real time, observe flares and jets as they are launched. Each improvement in technology brings new opportunities for discovery. Theoretical physics is also advancing. Researchers continue to work on the problem of quantum gravity, trying to develop a framework that can describe what happens at the singularity, where general relativity breaks down. Ideas like string theory, loop quantum gravity, and various other approaches offer different perspectives on this challenge. While a complete theory of quantum gravity remains elusive, progress is being made, and someday we may understand what truly lies at the heart of a black hole. Closer to home, astronomers are working to understand the history of our own galaxy's central black hole. What was Sagittarius A star like in its active phases? How did it influence the formation of the Milky Way? Are there smaller black holes orbiting the central giant, remnants of galaxies that the Milky Way swallowed long ago? These questions connect the exotic physics of black holes to the specific history of our cosmic neighborhood. The study of black holes touches so many areas of physics and astronomy. It involves general relativity and quantum mechanics, stellar evolution and galaxy formation, high-energy astrophysics and cosmology. To understand black holes is to engage with some of the deepest questions we can ask about the nature of space, time, matter, and energy. It is a field that rewards curiosity and demands creativity, offering puzzles that have challenged the best minds in physics for over a century. As you rest in this moment, perhaps feeling a growing sense of relaxation spreading through your body, know that the study of black holes continues. Right now, even as you listen to these words, astronomers are collecting data from telescopes around the world and in orbit. They are analyzing observations, running simulations, debating interpretations. The quest to understand these cosmic enigmas is ongoing, a human endeavor that spans cultures and generations, driven by the simple desire to know what is out there in the vast darkness between the stars. Let us begin now to draw our exploration toward a close. We have traveled far tonight, from the edge of our own solar system to the hearts of distant galaxies, from the birth of the universe to its eventual heat death. We have contemplated objects so massive they strain our ability to comprehend, forces so strong they warp the very fabric of reality. And through it all, you have remained here, safe and comfortable, a conscious being pondering the wonders of the cosmos. The supermassive black holes we have discussed are the anchors of the universe, the stable points around which galaxies spin, the regulators of cosmic growth, the ultimate fate of matter that falls within their grasp. They are not malevolent, though they are powerful. They are not intentional, though their effects are profound. They simply are expressions of the laws of physics playing out on scales that dwarf human concerns. And yet, in a strange way, they connect to us. The galaxy we live in is shaped by its central black hole. The heavy elements in our bodies were distributed by supernova explosions that also created smaller black holes. The very space we move through is the same space that curves so dramatically around these cosmic giants. We are part of the same universe, subject to the same rules, participating in the same unfolding story. There is comfort in this connection, if you allow yourself to feel it. The universe is not indifferent to you, even if it is not conscious. It created you, from atoms forged in stars and scattered across space. It sustains you through the steady light of a sun that will continue to burn for billions of years. It contains you within a galaxy that is held together by gravity, anchored by a black hole that has been there since the galaxy's earliest days. You belong here, in this moment, in this place, in this cosmos that is your home. The black holes will continue their patient vigil at galaxy centers for eons to come. Stars will be born and die. Galaxies will merge and reform. The universe will expand and cool. Through it all, these gravitational anchors will persist, outlasting almost everything else, silent witnesses to the passage of cosmic time. And somewhere in that vastness, on a tiny planet orbiting an ordinary star, creatures with curious minds will continue to look up at the night sky and wonder about the nature of things. That wondering is precious. It is what distinguishes us, what gives our brief existence meaning beyond the mere continuation of genes and cells. We are the universe becoming aware of itself, matter arranged to contemplate matter, energy flowing in patterns that ask questions about their own nature. The black holes cannot do this. For all their power and majesty, they cannot wonder. They cannot feel awe. They cannot appreciate the beauty of a sunset or the mystery of their own existence. Only conscious beings can do these things, and that makes consciousness one of the rarest and most valuable phenomena in the cosmos. As you prepare to drift into deeper relaxation, or perhaps toward sleep, carry with you the knowledge that you have done something remarkable tonight. You have thought about objects billions of light years away, contemplated timescales that stretch across eternity, engaged with ideas at the frontier of human understanding. That is no small thing. That is the best of what humanity can offer, the spark of curiosity that has driven our species from caves to telescopes, from ignorance to insight. The universe is vast and dark, filled with dangers we will never face and wonders we may never see. But it is also the ground of our being, the source of everything we are, the stage on which the drama of existence plays out. The black holes that anchor, galaxies are part of this drama, major characters in a story that includes you as well. Their shadows stretch across space and time, touching everything they encounter, shaping the cosmos on the larger scales. Tomorrow, when you wake, the stars will still be there. The galaxies will still be spinning. The black holes will still be waiting in their patient darkness. And you will still be you, a conscious being with the remarkable ability to think about all of it, to feel something in response, to find meaning and beauty in the mere fact of existence. That is a gift worth cherishing, a capacity worth celebrating, a responsibility worth honoring. Rest now. Let the images of cosmic giants fade gently from your mind, like stars fading into the light of dawn. Let your breathing continue in its slow, steady rhythm, natural and unforced. Let your body sink deeper into whatever surface supports you, held by the same gravity that shapes black holes, part of the same universe that contains them. The shadow that devours sunsets is real, but it is far away. Here, in this moment, you are safe. Here in this moment, you can simply be, without striving, without worrying, without needing anything more than what is already given. The cosmos cradles you as it cradles everything, and in that cradle, peace is possible. There are hundreds of billions of galaxies in the observable universe, each one a vast collection of stars and planets and gas and dust. Almost every one of these galaxies hosts a supermassive black hole at its center, a gravitational anchor holding everything together. If you could somehow count all the supermassive black holes in the cosmos, the number would be staggering. Hundreds of billions of these giants scattered across the reaches of space. And yet, despite their numbers, supermassive black holes represent only a tiny fraction of the universe's total mass. Most of the matter in the cosmos is diffuse gas floating between galaxies or bound in the halos of dark matter that surround galaxy clusters. The black holes, for all their power, are small compared to the structures they inhabit. They are concentrated points of mass in a universe that is mostly empty space. This contrast between the black hole's small size and large influence is worth pondering. A supermassive black hole might be 1 billion times more massive than our Sun, but a galaxy contains hundreds of billions of stars. The black hole is a tiny fraction of its galaxy's mass, yet it can determine the fate of much of that galaxy's gas, regulating star formation and shaping galactic evolution. Influence in the universe is not always proportional to size. Sometimes a small thing in the right place can have effects far beyond what its mass alone would suggest. There might be a lesson in this for human life as well. We are small, vanishingly small compared to the cosmos. Our planet is a mote of dust in a sunbeam. Our Sun is one of hundreds of billions of stars in a galaxy that is itself one of hundreds of billions of galaxies. And yet, conscious beings can have influence beyond their physical size. Ideas can spread, actions can ripple outward, creativity can spark new possibilities. We may be tiny, but we are not insignificant. The universe operates on principles that we are still learning to understand. Gravity, the force that creates black holes, also binds us to our planet and holds our moon in orbit. Electromagnetism, the force that produces the light by which we see black holes, also carries the nerve impulses in our brains and powers the devices that let us communicate. The strong and weak nuclear forces that govern atomic nuclei also enable the fusion reactions that make stars shine and produce the heavy elements in our bodies. Everything is connected through these fundamental forces, every phenomenon an expression of the same underlying physics. This unity is perhaps the deepest insight that modern science offers. Beneath the diversity of cosmic phenomena, there is an elegant simplicity, a small set of laws that govern everything from quarks to quasars. A black hole follows the same equations as a bowling ball, just taken to an extreme limit. The light from a distant quasar obeys the same principles as the light from a candle on your bedside table. Understanding one helps us understand the other, and understanding both helps us understand ourselves. Let these thoughts accompany you into whatever state of rest you seek tonight. The universe is vast, but it is comprehensible. It is strange, but it is not hostile. It contains wonders beyond counting, from the spiral arms of galaxies to the delicate structure of a snowflake, from the fusion furnace of a star to the gentle pulse of your own heartbeat. All of it belongs to the same cosmos. All of it follows the same rules. All of it is connected in ways both obvious and hidden. The supermassive black holes at galaxy centers are among the most extreme objects we know. They push the laws of physics to their limits, creating regions where time slows, space curves, and matter disappears forever. They are laboratories of extreme gravity, testbeds for our theories of the universe. And they are also, in their own way, beautiful, sources of awe and wonder that remind us how much remains to be discovered. Decades from now, when new telescopes reveal new details about these cosmic giants, the fundamental mystery will likely remain. We may learn exactly how they form, how they grow, how they influence their surroundings in ever more precise detail. But the basic strangeness of a black hole, a region from which nothing can return, a place where our normal understanding of space and time breaks down, will continue to inspire curiosity and wonder. Some mysteries are inexhaustible, offering new depths no matter how deeply we explore. For now, let the mystery rest gently in your awareness. You do not need to solve it. Do not need to understand everything. Do not need to achieve anything at all. The universe is patient. The black holes are patient. And you can be patient too, allowing yourself this time of quiet contemplation, this respite from the demands of waking life. The night sky is always there, waiting for anyone who cares to look up. The stars we see are neighbors, close companions in a galaxy that spans 100,000 light years. Beyond them, in depths we cannot see with naked eyes, lie other galaxies, other black holes, other wonders without number. Knowing they are there, even if we cannot see them, enriches our experience of the cosmos. It tells us that reality extends far beyond the small circle of our immediate perception, that the universe is vast and mysterious and full of things we have not yet imagined. Rest in that vastness. Let it hold you. Let the knowledge of black holes and galaxies and the great structures of the cosmos be a pillow beneath your thoughts, supporting you as you drift into deeper relaxation. The shadow that devours sunsets is real, but it is also remote, a marvel to contemplate from the safety of your comfortable perch on a small blue planet, orbiting an ordinary star. You have journeyed far tonight, in imagination, if not in body. You have visited the hearts of galaxies, the edges of event horizons, the distant reaches of cosmic time. Now let yourself return slowly and gently to the present moment, to the here and now where your body rests and your breath flows. The journey outward always leads back home, and home is where you are, wherever that may be. The black holes will keep their secrets for another night. The universe will continue its patient unfolding, and you, a conscious spark in the vast darkness, will find whatever rest you seek, cradled by gravity, warmed by a nearby star, connected to everything that is and was and ever will be. Sleep well, or simply rest well, knowing that you are part of something larger than yourself, something ancient and ongoing and filled with wonders. The shadow that devours sunsets is one of those wonders, and you have met it tonight, in your own way, on your own terms. That meeting is a gift, and you can carry it with you into whatever comes next. The cosmos is your home. The black holes are your distant kin, expressions of the same physical reality that gives rise to stars and planets and life. In contemplating them, you have contemplated yourself, for you are made of the same stuff, bound by the same forces, participating in the same grand story. May that contemplation bring you peace, and may your rest be deep and restorative. The night awaits, gentle and welcoming. Let yourself sink into it, as naturally as a leaf settling onto still water. The universe will hold you. It always does. Let us linger here a little longer, in this space between waking and sleeping, between the everyday world and the cosmic depths. The journey we have taken tonight has covered vast distances and enormous spans of time, but it has also been a journey inward, a meditation on the nature of existence and our place within it. The black holes we have discussed are real physical objects, but they are also symbols, embodiments of the unknown that lies at the edges of human understanding. Consider for a moment what it means that we can even think about these things. Somewhere in the universe, roughly 4 billion years ago, simple molecules in a primordial ocean began to copy themselves. Through countless generations, these replicators became more complex, developing membranes to contain themselves, metabolisms to fuel themselves, eventually nervous systems to coordinate their movements. And now, after all that time, here you are, a descendant of those ancient molecules, lying in comfort and contemplating objects at the centers of galaxies. The chain of causation that connects you to those first replicators is unbroken. Every ancestor you have ever had survived long enough to reproduce, passing down the genetic information that would eventually become you. Every cell in your body carries the legacy of 4 billion years of evolution, optimized by natural selection for survival in a world of predators and prey, of scarcity and competition. And yet, despite all that optimization for immediate practical concerns, you have developed the capacity for something seemingly useless from an evolutionary standpoint, the ability to wonder about the universe. Why should a collection of cells care about black holes? Why should a product of natural selection spend time thinking about objects it will never encounter, distances it will never travel, timescales that dwarf its brief existence? These are good questions, and the answers are not entirely clear. Perhaps wonder is a byproduct of the cognitive abilities that made our ancestors successful hunters and gatherers, pattern recognition and causal reasoning taken to their logical extremes. Perhaps there is some deeper connection between consciousness and cosmos, some reason why matter organized into thinking beings should naturally seek to understand itself. Whatever the reason, here we are, minds contemplating the universe that produced them. And in that contemplation, there is something sacred, or at least something precious and rare. The black holes themselves do not know they exist. The galaxies do not appreciate their own beauty. The stars burn without awareness of their role in creating the elements of life. Only conscious beings can do these things, can step back from the immediate press of survival and ask what it all means. The answer to that question, if there is an answer, may not be something we can put into words. Perhaps meaning is something we create rather than discover, a pattern we impose on the universe rather than something built into its structure. Or perhaps there is a deeper purpose, a cosmic significance to existence that we glimpse only dimly through the veil of our limited perceptions. Either way, the asking of the question is itself an act of meaning-making, a declaration that we are not merely passive observers, but active participants in the unfolding of reality. The black holes, in their patient darkness, seem to embody the opposite of consciousness. They are objects of pure physics, following the equations of general relativity without thought or intention. Matter falls in, and the black hole grows heavier. Energy radiates from the accretion disk, and the black hole grows hotter. Time slows near the event horizon, and the black hole distorts the very fabric of space-time. All of this happens automatically, mechanically, without the need for awareness or purpose. And yet, There is a strange beauty in this mechanical perfection. The black hole does what a black hole does, nothing more and nothing less. It does not strive or struggle, does not hope or fear, does not question its own existence. In a universe filled with complexity and uncertainty, the black hole is a kind of anchor, a fixed point that simply is what it is. There is almost a purity to this, a simplicity that contrasts with the messy complexity of living things. Perhaps there is something to learn from this contrast. We spend so much of our lives in striving, in wanting things to be different from how they are, in struggling against the currents of circumstance. The black hole offers a different model, one of acceptance and presence, of simply being without needing to become. This is not a suggestion that we should give up our goals or abandon our efforts to improve our lives and the lives of others. But there may be wisdom in sometimes stepping back from the endless striving, in allowing ourselves moments of simply existing, like black holes at the centers of galaxies, patient and still. This kind of presence is what we cultivate in meditation, in contemplation, in moments of rest like the one you are experiencing now. When you let go of the need to do something, to solve something, to achieve something, you touch a state of being that is older than humanity, older than life on Earth, as old as the universe itself. Existence does not require justification. It simply is, and you are part of it, and that is enough. The supermassive black holes we have discussed are extreme examples of existence without striving. They do not try to grow larger or smaller, do not work to attract more matter or repel what approaches. They simply exert their gravitational influence, and the universe responds accordingly. There is no ego in a black hole, no desire, no attachment. Just physics playing out across billions of years, shaping galaxies and regulating cosmic evolution without any need for intention. Humans cannot achieve this kind of egoless presence completely, nor should we want to. Our desires and intentions are part of what makes us human, part of what drives us to create, to love, to explore. But we can learn to hold our desires more lightly, to recognize that we are not separate from the universe that surrounds us, to find moments of peace in the midst of our striving lives. The night sky is a good teacher in this regard. When you look up at the stars, if you really look, if you really allow yourself to see what is there, something shifts in your awareness. The petty concerns of daily life recede. The worries about tomorrow, the regrets about yesterday, all of it fades in the face of the vast darkness sprinkled with points of light. You are reminded that you are small, but you are also reminded that you are here, that you exist, that you are part of something beautiful and mysterious and incomprehensibly large. The black holes are part of that something. They are the hidden hearts of galaxies, the gravitational anchors that hold everything in place, the ultimate destinations of matter that falls past their event horizons. They are also reminders of the limits of our knowledge, the places where our theories break down and mystery begins. In a universe that sometimes seems fully explained, fully understood, fully mapped by human science, the black holes remind us that there is still much to discover. Let this thought accompany you as your body continues to relax, as your breathing settles into its natural rhythm, as the tension in your muscles melts away like ice in spring. The universe is not fully known. The black holes hold secrets that will take generations to unravel. The story of existence is still being written, and you are part of the writing. Your choices and thoughts and experiences contributing to the ongoing evolution of consciousness on this small planet. That contribution matters, even if it seems small compared to the cosmic scales we have been discussing. A kind word, a moment of attention, a creative act, a gesture of love. These things ripple outward in ways we cannot always see. The universe is interconnected, and what happens in one place affects what happens elsewhere. Your existence changes the cosmic equation, however slightly, adding your unique perspective to the great chorus of being. The black holes, massive as they are, started from smaller beginnings. The seed that became Ton 618 or Phoenix A star was once just a concentration of matter in the early universe, a region slightly denser than its surroundings. Over billions of years, through steady accumulation and occasional mergers, that seed grew into the titan it is today. Growth is possible, change is possible, evolution is possible, even on cosmic scales. The same is true for you. You are not fixed, not static, not the same person you were a year ago or a decade ago. You are changing, growing, evolving in your own way. The experiences you have, the thoughts you think, the choices you make, all of these shape the person you are becoming. And that person will be different tomorrow than they are today, different next year than they are now. Change is the nature of things, at every scale from atoms to galaxies. Rest in this flow of change. Let yourself be part of the current rather than fighting against it. The universe is not standing still, and neither are you. The black holes are growing, the galaxies are spinning, the cosmos is expanding. Everything is in motion, everything is changing, and yet, paradoxically, there is also a deep stillness beneath all the motion, an unchanging awareness that observes the flux without being carried away by it. This stillness is available to you right now, in this moment. It is the still point at the center of your being, the eye of the hurricane, the silent space between thoughts. You do not have to create it or achieve it. You only have to notice it, to turn your attention toward it, to rest in its quiet presence. The black holes, for all their drama, exist in this stillness too. They are simply points where the fabric of space-time curves in on itself, expressions of pure geometry without narrative or struggle. Breathe in and feel your chest rise. Breathe out and feel your chest fall. This simple rhythm has been happening since the moment you were born, and it will continue until the moment you die. It does not require your attention, your effort, your intention. It simply happens, like a black hole simply exists, like a galaxy simply spins. You can let go into this automatic rhythm, trusting your body to breathe itself, trusting the universe to support you as it supports everything within it. The journey we have taken tonight has been long, and it is nearly time to rest. We have explored the nature of supermassive black holes, their enormous masses and impossible scales, their influence on the galaxies they inhabit, their role in shaping the evolution of the cosmos. We have contemplated what it would be like to fall into one of these cosmic monsters, experiencing the distortion of time and space as we approach the event horizon. We have considered the far future, when these black holes will be among the last complex objects in the universe winding down toward heat death. And we have reflected on our own place in this vast drama, small creatures with curious minds pondering the nature of existence. All of this contemplation has been a kind of journey, an expedition of the imagination that has taken us to places no human body could survive. And now, like any traveler returning home, we bring back what we have learned, what we have seen, what we have felt. The black holes are out there, real and powerful and mysterious, but they are also in here, in our minds, in our understanding, in the thoughts and images that will linger after these words fade. You have done something valuable tonight. You have exercised the capacity for wonder that, makes humans unique among the species of Earth. You have reached beyond the immediate concerns of survival and status to touch something larger, something eternal, something that connects you to the deepest structures of reality. That reaching is itself a kind of prayer, a gesture of openness toward the mystery that surrounds us. The universe does not offer answers to all our questions. The black holes keep their secrets, the singularities remain hidden, the ultimate fate of matter falling past the event horizon is unknown. But the questions themselves have value, shaping our relationship with the cosmos, orienting our attention toward the vast and the strange, reminding us that we live in a universe far more extraordinary than the narrow world of daily routine. Carry this sense of wonder with you as you move into whatever comes next, whether that is sleep or simply deeper relaxation. Let it inform your waking life as well. The awareness that beyond the traffic and the deadlines and the small frustrations, there is a cosmos of black holes and galaxies, of stars being born and stars dying, of gravitational waves rippling through space-time and light traveling across billions of years. This awareness does not solve practical problems or pay the bills, but it provides context, perspective, a sense of proportion that can make the challenges of life seem more manageable. The shadow that devours sunsets is real, but so are you. The black holes are powerful, but so is consciousness in its own way. The ability to think about these objects, to feel awe in their presence, to ask questions about their nature, this is a power of a different kind, a capacity that emerges from matter but transcends the blind mechanics of physics. You are the universe knowing itself, and that knowing is precious beyond measure. Rest now in this knowing. Rest in the awareness that you are part of something larger than yourself, something ancient and ongoing and filled with wonders. Rest in the peace that comes from letting go, from accepting your place in the cosmic dance, from trusting that the universe will continue its patient unfolding, whether you worry about it or not. The black holes will still be there tomorrow. The galaxies will still be spinning, and you will still be you, a little more rested, a little more at peace, carrying the memory of this journey into the day ahead. The darkness outside your window, if it is night where you are, is the same darkness that fills the space between stars. The silence around you, if it is quiet, is cousin to the silence of interstellar space. You are already connected to the cosmos, every moment of every day, whether you notice it or not. Tonight, you have noticed. And in that noticing, something has shifted, something subtle but real, a deepening of your relationship with the universe that gave you birth. May that relationship continue to deepen. May your curiosity about the cosmos never fade. May you find moments of wonder in the midst of ordinary life, glimpses of the extraordinary hiding within the everyday. And may you rest well tonight, cradled by gravity, warmed by your nearby star, a conscious being in a universe that seems, against all odds, to have produced conscious beings who can wonder about black holes and galaxies and the nature of existence itself. The story continues. The black holes grow, the galaxies evolve, the universe expands, and somewhere, on a small planet orbiting an ordinary star, a creature made of stardust pauses to contemplate the vastness of which it is a part. That creature is you. That moment is now. And that contemplation is one of the most remarkable things happening anywhere in the known cosmos. Rest well. Dream of stars if you dream at all. And know that the shadow that devours sunsets is watching over you in its own strange way, a silent guardian at the heart of the galaxy that is your home. The universe loves you in the only way a universe can love, by existing, by allowing you to exist, by providing the conditions under which consciousness can emerge and flourish. That love is not personal, not intentional, not directed specifically at you, but it is real as gravity, as real as the light of stars, as real as the gentle pressure of the bed beneath your body. Accept this cosmic love as you drift into rest. Let it hold you as you let go of the day's concerns. The black holes are ancient, and they will wait. The mysteries are patient, and they will keep. For now, there is only this moment, this breath, this quiet awareness of being alive in a universe of wonders. Sleep well. The cosmos is dreaming with you. As you settle more deeply into this state of rest, let us spend a few more moments with the giants that have been our companions tonight. The supermassive black holes, those anchors of galaxies, have revealed themselves to be far more than simple gravitational traps. They are dynamic engines that shape their surroundings, cosmic regulators that influence the birth and death of stars across vast regions of space, mysterious objects that challenge our understanding of physics at its most fundamental level. We have talked about the largest of these black holes, the titans like TON 618 and Phoenix A star that contain tens of billions of solar masses. But there is a whole spectrum of supermassive black holes out there, ranging from these behemoths down to objects containing only millions of solar masses. Our own Sagittarius A star, with its 4 million solar masses, is on the smaller end of this range, and yet even this relatively modest black hole would be devastating if it were placed in our solar system. Its event horizon would extend beyond the orbit of Mercury, swallowing the innermost planet completely. The diversity of supermassive black holes reflects the diversity of galaxies themselves. Spiral galaxies like our Milky Way tend to have black holes in the millions to low billions of solar masses. Giant elliptical galaxies, those huge collections of old stars that form when spirals merge together, often host the largest black holes, approaching or exceeding 100 billion solar masses. The relationship between galaxy type and black hole size is another clue to the coevolution that links these objects, the dance of growth that plays out over billions of years. There are also intermediate mass black holes, objects that fall between the stellar mass black holes formed from collapsed stars and the supermassive giants at galaxy centers. These intermediate objects, containing thousands to hundreds of thousands of solar masses, are harder to find because they do not produce the same dramatic signatures as their larger cousins. But astronomers are beginning to detect them in the dense cores of globular clusters and in the wreckage of smaller galaxies that have been torn apart by larger neighbors. They may represent the building blocks from which supermassive black holes are assembled, smaller pieces that merge together over cosmic time to create the giants we see today. The study of intermediate mass black holes is a frontier of current research. If we can understand how these objects form and grow, we may gain insight into the origins of supermassive black holes, solving the puzzle of how they got so big so fast. Each new detection adds to our picture. Each observation constrains our theories. Each breakthrough brings us closer to understanding the life cycle of black holes across all mass scales. There is something deeply satisfying about the way scientific knowledge builds upon itself. The observations of one generation become the foundations for the theories of the next, which in turn guide new observations that refine or overturn those theories. This process has been ongoing for centuries, and it shows no signs of stopping. The black holes that seemed like mathematical curiosities a century ago are now well-established members of the cosmic zoo. The gravitational waves that were mere theoretical predictions a few decades ago are now routinely detected by instruments on Earth. Who knows what the next century will bring? Perhaps we will finally understand what happens at the singularity, that point of infinite density, at the heart of every black hole where our current theories break down. Perhaps a theory of quantum gravity will reveal that singularities do not really exist, that nature has some way of smoothing out the infinities that appear in our equations. Or perhaps we will discover something even stranger, some aspect of reality that we cannot currently imagine, but that will seem obvious to future generations. The history of science is full of such surprises. Before Newton, no one imagined that the same force that makes apples fall from trees also keeps the moon in orbit around the Earth. Before Einstein, no one imagined that space and time were aspects of a single fabric that could be warped by mass and energy. Before the discovery of quantum mechanics, no one imagined that particles could exist in multiple states simultaneously until observed. Each revolution in understanding opened new questions even as it answered old ones. The black holes are part of this ongoing story, chapters in a book that is still being written. They challenge us to think more deeply about the nature of space and time, about the limits of classical physics, about the ultimate fate of matter and energy. They are not just objects to be catalogued, but puzzles to be solved, mysteries that call forth our best efforts at understanding. And yet, for all their mystery, black holes are also strangely familiar. The gravity that shapes them is the same gravity that keeps your feet on the ground. The space-time that curves around them is the same space-time that you move through every day. The light that bends near their event horizons is the same light that lets you see the world around you. Black holes are extreme, but they are not alien. They are expressions of the same physical laws that govern everything else in the universe, taken to their logical limits. This familiarity is important. It means that by studying black holes, we learn not just about exotic objects in distant space, but about the fundamental nature of reality itself. The insights gained from black hole physics have applications far beyond astrophysics, influencing our understanding of thermodynamics, quantum mechanics, and the structure of space-time. Black holes are natural laboratories for testing ideas that we cannot probe in any other way. One of the most famous insights from black hole physics is the connection between black holes and thermodynamics, the branch of physics that deals with heat and energy. In the 1970s, physicists realized that black holes have a temperature and an entropy, properties usually associated with ordinary matter. This realization came as a surprise, since black holes were thought to be perfectly simple objects, characterized only by their mass, spin, and electric charge. The entropy of a black hole is proportional to the area of its event horizon, not its volume. This is strange because for ordinary objects, entropy is proportional to volume. A box of gas has more entropy if the box is bigger, because there are more ways to arrange the gas molecules. But for a black hole, all the disorder is somehow encoded on the two-dimensional surface of the event horizon, as if the interior volume does not matter. This observation led to ideas about holography, the notion that the information content of a region of space might be encoded on its boundary rather than in its bulk. Some physicists believe this principle might extend beyond black holes to the universe as a whole, suggesting that our three-dimensional reality might be a kind of projection from a two-dimensional surface. These ideas are speculative and controversial, but they show how black hole physics can lead to profound questions about the nature of reality. Another famous puzzle involves information. When something falls into a black hole, what happens to the information it carried? classical physics suggests that the information is lost forever, trapped behind the event horizon and eventually crushed into the singularity. But quantum mechanics says that information can never truly be destroyed. This apparent contradiction, known as the black hole information paradox, has been debated by physicists for decades. Various solutions have been proposed. Perhaps the information leaks out slowly through Hawking radiation, encoded in subtle correlations between the particles emitted over billions of years. Perhaps the information falls through to another region of spacetime, emerging from a white hole somewhere else. Perhaps our understanding of quantum mechanics or general relativity needs to be modified in ways we have not yet imagined. The paradox remains unresolved, a reminder that even our best theories may be incomplete. These deep questions might seem abstract and distant from daily life, but they touch on fundamental issues about the nature of existence. What is information? Is there a fundamental level of reality beneath the particles and forces we observe? What happens at the boundaries where our theories fail? These are questions that philosophers have pondered for millennia, and black holes are bringing them back into the spotlight in new ways. As you rest in the quiet of this moment, these questions do not need answers. They can simply float in your awareness, points of curiosity that connect you to the great project of human understanding. The black holes are teachers as well as wonders, inviting us to think more deeply, to question our assumptions, to remain humble in the face of the unknown. The universe has been teaching these lessons for billions of years, long before humans existed to learn them. The black holes formed, the galaxies evolved, the cosmos expanded, all without any conscious observers to appreciate the show. And then, in the blink of a cosmic eye, life emerged on at least one small planet, evolved into conscious beings, developed science and mathematics, and began to figure out what was happening out there in the vast darkness. That emergence is itself one of the great mysteries. Why should the universe produce observers? Why should matter organize itself into forms capable of contemplating their own existence? These questions may have answers that we can eventually discover, or they may be beyond the reach of human understanding. Either way, the fact that we are here, asking these questions, seems remarkable against the backdrop of cosmic indifference. The black holes do not care that we exist. They will continue their patient growth, whether we observe them or not. The galaxies do not need our appreciation to spin in their ancient patterns. The universe does not require consciousness to function. And yet, consciousness has emerged, has looked up at the sky, has asked what those points of light might be. That asking seems to matter somehow, even if we cannot say exactly why. Perhaps the universe is more than it appears to be. Perhaps there is a deeper significance to existence that we glimpse only dimly through our limited perspectives. Or perhaps we are simply lucky, improbable arrangements of matter that happen to develop the capacity for wonder, enjoying a brief moment of awareness before dissolving back into the cosmic flow. Either way, the experience of contemplating black holes, of feeling the vastness and the mystery, is real and valuable in itself. Let that value accompany you as you move toward rest. You have done something meaningful tonight, engaging with ideas that stretch the boundaries of human understanding. You have participated in the great human tradition of curiosity, the drive to know that has propelled our species from campfires to telescopes. That participation matters, regardless of whether it leads to any practical outcome. The black holes will continue their vigil at galaxy centers. The universe will continue its expansion into the endless dark. And conscious beings, wherever they exist in the cosmos, will continue to wonder about the nature of things. You are part of that wondering, part of that great project of understanding that spans generations and transcends individual lifetimes. Rest now in that belonging. Rest in the knowledge that you are connected to something larger than yourself, something that began before you were born and will continue after you are gone. The black holes are part of that something, and so are the stars, and so are the galaxies, and so are you. Everything belongs to the same vast tapestry of existence, woven from the threads of matter and energy in space and time. The shadow that devours sunsets has been with us from the beginning of our journey tonight. It will stay with you as you drift into rest, a symbol of the vast and the mysterious, the powerful and the patient. It does not threaten. It does not approach. It simply exists, out there in the cosmic dark, a reminder that the universe is far stranger and more wonderful than we often remember. Tomorrow, the world will claim your attention again. There will be tasks and obligations, joys and frustrations, the whole messy business of being human. But somewhere beneath the surface of daily life, the memory of tonight's journey will remain, a quiet awareness that you live in a universe of black holes and galaxies, of wonders without number, of mysteries without end. That awareness is a gift. Carry it lightly, without grasping, without making it into something it is not. The universe does not ask for worship or obedience. It simply offers itself to those who care to look, revealing layer upon layer of complexity and beauty. The black holes are part of that offering, dark jewels hidden at the hearts of galaxies, waiting for curious minds to find them. You have found them tonight. You have looked into the abyss, and the abyss has looked back, indifferent but not hostile, strange but not entirely alien. In that meeting, something has been exchanged, some understanding, some appreciation, some connection between a finite human consciousness and the infinite depths of cosmic reality. Let that exchange complete itself as you rest. Let the images and ideas we have explored settle into your memory, finding their places among everything else you know and feel and have experienced. They do not need to stay at the forefront of your awareness. They can sink down into the depths, like sediment, settling to the bottom of a lake, enriching the soil of your inner life. The black holes at galaxy centers are called eternal guardians by some, silent watchers that have been there since galaxies first formed and will remain until galaxies fade away. They guard nothing in particular, have no duty or purpose, but the name captures something of their quality nonetheless. They endure. They persist. They remain when everything else has changed. You can draw some of that quality into yourself. Not the darkness or the danger, but the endurance, the persistence, the ability to remain centered while everything around you changes. The black holes achieve this through gravity, through the sheer concentration of mass that warps space and time around them. You can achieve something similar through attention, through the practice of coming back again and again to the present moment, to the awareness that underlies all experience. This practice does not make problems disappear. It does not grant immunity from the challenges of life, but it can provide a stable foundation, a still point from which to engage with whatever arises. The black holes are stable in their own way, unchanging except for the slow growth of their mass over billions of years. You can find your own stability, your own center, your own way of remaining grounded while life swirls around you. The night is deep now, and rest is calling. Let yourself answer that call, releasing any remaining tension, any lingering thoughts about what should be or could be. There is only what is, this moment, this breath, this quiet awareness of being alive. The black holes will be there when you wake, the universe, will have continued its patient evolution. The stars will have moved imperceptibly in their orbits. The galaxies will have rotated by tiny fractions of a degree, and the cosmos will be very slightly larger than it was when you fell asleep. These changes are too small to notice on human timescales, but they are happening, continuously, endlessly, the great machine of the universe grinding forward into an unknown future. You are part of that future, for as long as you live. Your choices and actions contribute to the unfolding of events, however slightly. The story is not fixed in advance. It is being written moment by moment, by everything that exists, including you. That is both a responsibility and a freedom, a burden and a gift. For now, the burden can wait. For now, only rest matters, only the settling of body and mind into the quiet depths of night. The cosmic journey is over for now, but it never truly ends. Every time you look up at the stars, every time you wonder about the nature of things, the journey continues. Sleep well, traveler among the stars. The universe holds you gently, as it holds everything. The shadow that devours sunsets watches from afar, patient and eternal. And somewhere deep in your consciousness, a spark of understanding glows, a tiny light in the vast darkness, proof that matter can know itself, that existence can contemplate existence, that even in a universe of black holes and entropy, something like meaning can emerge. That spark is precious. Guard it well, and when you wake, carry it forward into whatever the day may bring. The journey continues, the wonder remains, and the black holes keep their ancient vigil now and forever, in the hearts of galaxies scattered across the infinite dark. In these final moments of our journey together, let us return once more to the image that began our exploration, the shadow that devours sunsets. When you first heard those words, they painted a picture of darkness and destruction, of something vast and terrible lurking in the cosmic void. And in a sense, that picture is accurate. Black holes do destroy what falls into them. They do swallow light and matter with equal indifference. They are, by any measure, among the most extreme and dangerous objects in the universe. But as we have explored together, there is so much more to these cosmic giants than simple destruction. They are the architects of galaxies, the regulators of cosmic evolution, the laboratories where the deepest truths of physics reveal themselves. Without supermassive black holes, the universe would look very different. Galaxies might be chaotic and unstable, lacking the gravitational anchor that holds them together. Star formation might proceed unchecked, creating blazing infernos of light that burn out too quickly. The heavy elements that make up your body might not have been distributed through space in the same way, scattered by the supernovae and jets that black holes help to trigger. In this sense, the black holes are not destroyers, but creators, or at least contributors to the creative process that has made the universe what it is. The very atoms that compose your flesh were forged in stars that lived and died in galaxies, anchored by supermassive black holes. The carbon in your cells, the oxygen in your breath, the iron in your blood, all of it has a history that stretches back to the fiery hearts of ancient stars, and those stars were influenced by the gravitational dance of their host galaxies. You are, in a very real sense, a product of black hole physics. Not directly, of course. No black hole had any intention of creating you. But the chain of causation that leads from the early universe to this moment, with you listening to these words, runs through the supermassive black holes at galaxy centers. They are part of your ancestry, as surely as the stars that made your atoms and the planet that supports your life. This cosmic ancestry connects you to everything else in the universe. Every atom in your body has a history that can be traced back to the Big Bang, through generations of stars and galaxies, through accretion disks and supernova explosions, through the slow accumulation of matter over billions of years. You are not separate from the cosmos. You are an expression of it, a local concentration of universal patterns, a way the universe has found to know itself. The black holes express these same universal patterns, just taken to an extreme. They are gravity made manifest, space-time curved beyond recognition, matter compressed beyond all normal limits, and yet they follow the same laws that govern everything else, from falling apples to orbiting planets to the expansion of space itself. In understanding black holes, we understand something fundamental about the nature of reality. That understanding is incomplete, as we have discussed. The singularities at black hole centers remain mysterious. The information paradox remains unresolved. The quantum nature of space-time remains to be discovered. But the incompleteness of our knowledge is not a failure. It is an invitation, a call to further exploration, a reminder that the universe still has secrets to reveal. You have accepted that invitation tonight, at least for a while. You have journeyed in imagination to places no human body can go, contemplated objects that dwarf all human constructions, pondered questions that have occupied the greatest minds in physics. That journey has not changed the black holes in any way. They will continue their existence exactly as before, indifferent to human attention. But the journey may have changed you in subtle ways that will unfold over time. Perhaps you will look at the night sky differently now, knowing what lurks at the center of the band of light that stretches overhead. Perhaps you will feel a greater sense of connection to the cosmos, recognizing that the same forces that shape black holes also shape your daily life. Perhaps you will simply carry a quiet awareness that reality is far stranger than ordinary experience suggests, that the universe contains wonders beyond counting. Whatever you carry forward from tonight, let it be held lightly. The cosmic perspective is not meant to overwhelm or diminish. It is meant to expand, to liberate, to provide context for the challenges and joys of human life. The black holes are not more important than your relationships, your health, your everyday concerns. They are simply different, expressions of the same reality at a different scale. Your scale, the human scale, is where you live. It is where love and friendship happen, where meaning is made and shared, where the practical business of survival and flourishing takes place. The cosmic scale provides backdrop and context, but it is not where your life unfolds. You do not need to become an astronomer or a physicist to honor what you have learned tonight. You only need to remember, occasionally, that you are part of something vast. The black holes will remind you if you let them. On clear nights, when the stars are visible, you can look toward the center of the Milky Way and know that Sagittarius A star is there, hidden by clouds of dust and gas, but present nonetheless. You can imagine the gentle warping of space-time around that region, the slow drift of stars orbiting their gravitational anchor. And you can feel, if you choose, a kinship with that distant point of darkness, a recognition that you and it are both expressions of the same physical reality. This kinship is not mystical or supernatural. It is simply the recognition of connection, the awareness that everything in the universe is made of the same fundamental stuff and obeys the same fundamental laws. The atoms in your body and the atoms in a black hole's accretion disk are the same kinds of atoms. Hydrogen and helium and carbon and oxygen, just arranged differently and in different amounts. The forces that shape your cells and the forces that shape galaxies are the same forces, gravity and electromagnetism and the nuclear interactions just operating at different scales. Understanding this unity is one of the great achievements of modern physics. Before the scientific revolution, humans thought the heavens were made of different stuff than the Earth, that celestial objects followed different rules than terrestrial ones. Now we know that there is only one universe, one set of physical laws, one continuous fabric of space-time that stretches from here to the most distant quasar. That unity is beautiful, and it is the foundation of everything we have discussed tonight. As you prepare for final rest, let that unity settle into your awareness. You are not separate from the cosmos. You are the cosmos, expressing itself in a particular form for a particular span of time. The black holes are also the cosmos, expressing itself in a very different form for a very different span of time. Both expressions are valid. Both belong. Both contribute to the rich tapestry of existence. The shadow that devours sunsets is real, but it is not coming for you. It is far away, doing what black holes do, following the laws of physics with perfect obedience. And you are here, doing what conscious beings do, thinking and feeling and wondering about your place in the scheme of things. Both of you, the black hole and you, are part of the same story. That story began nearly 14 billion years ago, in the hot, dense state we call the Big Bang. It will continue for unimaginable ages to come, through the slow cooling and darkening of the universe, through the evaporation of black holes over timescales too long to comprehend. You are here for a brief chapter of that story, a flicker of awareness in the long night of cosmic time. Make that flicker count, not by achieving great things necessarily, but by being fully present to your experience, by appreciating the wonder of existence, by connecting with others who share this strange condition of consciousness. The black holes cannot do these things. Only you can. That is your unique contribution to the universe, the gift that conscious beings offer to a cosmos that is otherwise blind and silent. Rest now, holding these thoughts loosely. The night will pass, the morning will come, and life will resume its ordinary pace. But somewhere in you, the memory of this journey will remain, a seed of cosmic awareness that can flower whenever you choose to water it. The black holes send no message. They have no wisdom to impart. They simply exist, vast and patient and strange. But your encounter with them tonight has been meaningful nonetheless, a moment of connection between a finite mind and an infinite universe. Sleep well. The cosmos dreams with you. The darkness outside is gentle now. The stars continue their slow wheeling across the sky, following paths laid down by gravity billions of years ago. Somewhere out there, beyond the visible edge of the universe, black holes are feeding and growing. Galaxies are colliding and merging. Stars are being born in clouds of glowing gas. The cosmic machine continues its work, indifferent to whether anyone observes it. But you have observed it tonight, at least in imagination. You have cast your awareness outward to the edges of the known, to the hearts of distant galaxies, to the event horizons of the largest black holes ever found. That casting is itself a kind of miracle, consciousness reaching across light years, touching objects it can never physically contact, feeling something in response to their existence. What you have felt tonight is yours to keep. The sense of scale, the awareness of cosmic time, the recognition of your place in something vast and ancient. These are gifts that cannot be taken away. They may fade from immediate awareness, pushed aside by the demands of daily life, but they remain in you, ready to resurface whenever you turn your attention back to the sky. The supermassive black holes at galaxy centers are among the most patient objects in existence. They have waited billions of years already, and they will wait billions more. In their presence, human urgency seems almost comical. The frantic rushing about of creatures who think their deadlines and appointments are important. And yet, human urgency is important, at least to humans. The cosmic perspective does not invalidate human concerns. It simply places them in a larger context. You can hold both perspectives, the human and the cosmic, different angles on the same beautiful reality we all share. The shadow that devours sunsets waits patiently at the heart of its distant galaxy, an eternal guardian. The universe continues its ancient dance, galaxies spinning, stars burning, black holes growing in the cosmic dark. And you are part of this dance, a conscious spark in the vast night, able to wonder about it all. That wondering is precious. Carry it with you into sleep and into waking. The cosmos holds you gently. Rest well now. The journey is complete.